Limit using factoring technique. Example, compute the following limits. Let's work on part A. If you look at part A, we have limit as x approaches to 3 of x squared minus 2x minus 3 over x minus 3. Here, if you try direct substitution, look at this screen carefully. If you substitute 3 in the denominator, you'll have 3 minus 3, which is equal to 0. You cannot have 0 in the denominator. So by direct substitution, you cannot get this limit. So what we try here is we are going to try the factoring technique. So let's see. Limit as x approaches to 3. If you factor the numerator, x squared minus 2x minus 3, factors are x minus 3 and x plus 1. Divided by, in the denominator, we have x minus 3. Remember one thing, because we have x minus 3 in the denominator, this is creating 0 in the denominator. Because if you plug in 3, it will be 0 in the denominator. So we want to remove x minus 3. That's why we are doing factoring. So when you go to this step here, you can see you have x minus 3 in the denominator, x minus 3 in the numerator. So now you can cancel those. So this factor which was there in the denominator get canceled. So now direct substitution will work. Check here. Because this is equal to limit as x approaches to 3 of x plus 1. There is no denominator. Meaning of that is the denominator is 1. So you can direct substitute because the function that you obtain here is a polynomial function or linear function. So if you plug in 3, it will be 3 plus 1. So it will be 3 plus 1. So the limit is equal to 4. Part B, we have to evaluate the limit as a approaches to -1, 2a minus 1 quantity squared minus 9 divided by a plus 1. If we try direct substitution here, if you plug in a equal to -1, so this is -1 plus 1, which will be 0 in the denominator. So if we have 0 in the denominator, limit does not exist. So we have to use a different technique. And I'm going to use factoring technique here. This is 9. If you look at this 9 carefully, this is 3 squared. 9 is same as 3 squared. So this 9 is same as 3 squared. That means if we look at this carefully in the numerator, this is like a minus 1, that's 1 quantity squared, minus 9 is 3 squared. So this is like a squared minus b squared, which can be written as a plus b times a minus b. So this can be written as the limit as a approaches to -1. So first we write a plus b, that will be 2a minus 1 plus 3. 2a minus 1 plus 3, that's a plus b. Now a minus b, 2a minus 1 minus 3. 2a minus 1 minus 3. Divided by, in the denominator, you have a plus 1. The reason we are doing this is we want to cancel this a plus 1 in few steps from now. Because of this a plus 1 in the denominator, we are getting 0 in the denominator. Let's simplify this and see what we get. We get limit as a approaches to -1. In the numerator, you have 2a. Then you have 3 minus 1, which is 2. Then in the other parenthesis, we have 2a minus -1 minus 3 is -4 divided by a plus 1. Still, we are not able to cancel anything because you have a plus 1 in the denominator. In the numerator, we have 2a plus 2 and 2a minus 4. So let's work a little more. Limit as a approaches to -1. Now here, if you look at these two carefully, in the first one, 2 is a common factor. If you factor that 2 out, you'll get 2 times a plus 1. Multiply 2. In the second parenthesis, 2 is a common factor. You may want to factor that out also. Then you get a minus 2. Divided by, in the denominator, you have a plus 1. So if you remember in the beginning, because of this a plus 1, the denominator was 0. Now here, you have a plus 1 in the denominator, a plus 1 in the numerator. Now you can cancel. So no more 0 in the denominator. We end up getting this one, limit as a approaches to -1. And here we have 2 times 2, which is 4 times a minus 2. Then if you substitute, you can perform direct substitution here. 4 times a is -1 because a approaches to -1 minus 2. So -1 minus 2, that is -3. -3 times 4 is -12. So the limit for the second part is -12.